And I'm going to go ahead and start recording now. So since I just started recording, let me just do a quick little recap, burn some time for people that are writing the notes. We're simplifying radicals. We're talking about square roots. So we're talking about what value was multiplied by itself to equal a perfect squared number. So again, 6 squared is 36. We can say that the 36 is a perfect squared number because 6 times 6 is 36. And we can say that 6 is the root of the perfect squared number. So what is the square root of 36? Well, its square root is 6 because we had to square the 6 to get to 36. All right, so how about square roots? What does the symbol look like? So the symbol of a square root is this. It looks like kind of the division symbol. The division symbol that you're used to looks something like that. And you would say 56 divided by 8. Well, this symbol kind of has a sharp check mark and then a line on top, and that is our square root symbol. Now, what you can't see, and they don't do this, they leave it exactly like that. That is assumed to being the square root. But there's actually an invisible number right here that we would write the number 2. We don't have to do that because it's assumed the 2 is there. This is called the index of a square root symbol. It's this number that would change in order to have a cube root, which is a third root, or a fourth root, or a fifth root, or a sixth root. So if I did something like the fifth root of something, let's say 32, then that's now saying that I want to know what number was multiplied by itself 5 times to get to 32. So that's what this little number means. So if you ever see a number there, it's not saying the square root, it's saying something like the third root or the fourth root. But we're not going to be talking about that. I just wanted to let you know what would be there if you ever saw that, ever. All right. So like I said, if you just see this symbol, it is assumed that there is a 2 right here, and it is the square root. All right, so how do square roots work? Well, I'm going to give a list of some commonly used square roots. So if I want to take the square root of these numbers, I want to know what number was multiplied by itself to get the number that is underneath. Now, the technical name for the number underneath is a radicand. So we want to know what 2 numbers multiply together to give us this radicand. Another technicality in math is that when we're just simplifying, we're finding what we call principal root. So the principal square root. The only thing that means is that every number we find is going to be positive. So what 2 numbers multiply together to give us 1? Well, 1 times 1 is 1. So the answer is 1. But you may also be thinking, what about -1 times -1? And you're right, -1 times -1 is also 1. But we are only going to be worrying about the positive roots. We don't worry about the negatives. So we're staying positive. Yay. All right, the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9, and the square root of 100 is 10. So you can see how squaring and square roots kind of have their similar relationship. Above, I squared each of those numbers, and as a result, I got their perfect squared answer. Now, if I square root all those perfect squares, it brings me back to their root or their square root. We're going to be working with this concept, but we're going to be working with values that are a little bit more challenging, just a little bit. Before I move on, any questions with this stuff? Hopefully this is kind of review from what you've seen in the past, but any questions with this? Not seeing anything in the chat, not seeing anything in the eyes of the people in the room? Okay. Oops, that was yesterday. So if I wanted to do the square root of 50, I would originally think to myself, well, what times what is 50? And it has to be the same number. Now, I know 5 times 10 is 50, but that doesn't help me. I can't think of a number that if I multiply it by itself, I get to 50. So I can't simplify this radical the same way I did those other problems. What I want to do is I want to think, well, is there a perfect square that goes into 50? So could I break up this radical into 2 other radicals that are being multiplied together to give me 50? So I just wrote out a bunch of square roots, and looking at these 10 square roots, would any of these numbers go in to 50 evenly? And one that jumps out is the square root of 25, because 25 times 2 is 50. So I'm claiming that the square root of 25 times the square root of 2 is the same thing as the square root of 50. Now I know the square root of 25 is 5. So I'm going to rewrite the square root of 25 to its equivalent of 5. And then I'm just going to, like many times with multiplication, we can disregard the symbol. And 5 square root 2 is our simplified radical. That is our goal for today. So I'm going to look at a number, see if there is a perfect square that goes into 50 or into our radicand, whatever it may be. And if I can find that, I'm going to break it up to the perfect squared times whatever made it equal the radicand, and then rewrite to get our answer. Now, what if I wanted you to take the square root of 12? So what perfect squared quantity goes into the square root of 12? So again, I want to break this up into 2 radicals. And I have a handy dandy list of square roots. And so when looking at this list, which number can go into 12? Well, I see over here that the square root of 4, which is 2, goes into 12. So I'm going to break up this radical, and I'm going to use the square root of 4 times the square root of what other number to equal 12? So the square root of 4 times the square root of 3 would equal the square root of 12. The square root of 4 is the same thing as 2. And so I get 2 square root 3. And that's my final answer. All right, I'm going to give you guys a couple to try, and then maybe we'll try some harder ones. But does anybody have any questions so far? All right, so let's try these two problems. I'm going to mute myself, see if people in person need any help, and then we can go over those answers. Sorry, I forgot to resume the recording, so I'll go ahead and repeat myself. 9 times 5 is 45. The square root of 9 times the square root of 5 is the square root of 45. The square root of 9 is 3. The square root of 5 is just simply the square root of 5. And so 3 times the square root of 5 is 3 square root 5. If you want to talk in a little bit of math slang, we would call that 3 root 5. So if anyone's ever talking radicals, specifically square roots, and I might slip up and say it because, you know, I'm cool and I talk math slang, 3 root 5 is the same thing as 3 times the square root of 5. Now, square root of 500. What two numbers multiply to give us 500? Now, again, I want to use a perfect square. So I recognize that the square root of 100 times the square root of 5 is 500. The square root of 100 is 10 times the square root of 5. And that gives me my result of 10 square root 5, or 10 root 5. All right, so now even though these are the easier ones, the harder ones aren't much harder. But let's kind of go up to maybe the medium level difficulty. So the medium level difficulty could look like this. Now all of a sudden I have numbers that are already on the outside and I have numbers on the inside. The number on the outside is just going to be called a coefficient, much like we would have if we had 2x. The multiplier, that constant multiplier, is a coefficient. The 32 is our radicand. That's what we want to split up. So what two numbers, when I multiply them together, do I get 32? So I have to go back to my square roots and figure out what perfect square goes into 32. This is a unique problem because there's actually a couple different ways that I could do this. With 32, maybe you want to say, all right, well, what if I were to cut it in half? It's an even number. That's usually an easy way to figure out what numbers multiply together. If it's even, just multiply a number by 2 and what gives you 32. So square root is 2, and then 2 times what is 32? Well, it's 16, which is a perfect square. Great, I'm almost done. So now I have 2 times the square root of 16 times the square root of 2. Let's simplify further. My next step, I still have that 2 there. It's still times the square root of 16 is 4 times the square root of 2. 2 times 4 is 8 times the square root of 2. So my answer is 8 root 2. So just remember that when you have a coefficient on front, it's being combined by multiplication. So 2 times the square root of 16 times the square root of 2 is the same thing as 2 times the square root of 32, which is the same thing as 8 root 2. Now notice what I didn't do. I didn't try to distribute the 2 to the 32 and call that the square root of 64. We can't do that. We can't just double the 32 and say it's 64 because it doesn't work like that. Technically, the 32 is somewhere between 5 and 6 because 32 is between 25 and 36. And so if I wanted to double a value, I'm going to be doubling 5 point something. Whereas if I were to double the 32 to turn to 64, that would give me 8. So be careful not to distribute this number into the radicand. They have to stay separate. Oh, before I move on to the next one, I did say that there were 2 different ways to do this problem. So let's take a look at another way of doing 2 times the square root of 2. What if you recognize, because it's just a math fact that you had stored in your brain, what about 8 times 4? 8 times 4 is also 32. So what if you would have done that? Nothing wrong with it. As I've said since day one, that even though there may be one right answer, there's multiple ways to get to that same answer. This is one of those instances where if I did it the first way or if I do it this way, neither way is more right than the other. This way is a little bit longer. It's going to take me one more step, but it gets me to the same answer. Because then what I have is 2 times 2, because that's the square root of 4, times the square root of 8. Or 4 times the square root of 8. Now, why this answer is different than the other one is because we're not done. Because there's actually another perfect square that goes into the square root of 8. What other perfect square goes into 8? Well, the square root of 4 times the square root of 2 is 8. And then what happens is I have 4 times 2 times the square root of 2, which is 8 square root 2. And that gives me to the same answer that I had above. So there isn't a right and wrong way of breaking up your radicand. You can break it up any way you want as long as you are finding perfect squares that go into the radicand. Now, the first way we did it, we lucked out and we got 16 times 2. So in one step, I could break it up. And then in the next step, I could simplify it. And then the last step, I could get to my answer. The other way is I recognized that 8 times 4 was 32. So I simplified it. But then I had to break up the square root of 8, simplify it, then get my answer. So sometimes it could take multiple steps to get to your answer. Sometimes it doesn't. Sure. So a question is about the process, so I'm just going to inquire about that. So when you say right out the factors, like you just factor it all out completely, like into. Gotcha. That. Okay. So here's a strategy Ms. Essex was saying, and I think it's a really good idea, is that once you start this problem, what if on the side you were just to write out all the factors that you know? And then once you do that, then you can pick the route that you want to take. So what I mean by that is factors are two numbers that multiply together to give you your desired number. So two numbers to give you a product. So factors of 32 would be 32 times 1, 16 times 2, 8 times 4, and then 5 doesn't go into it, 6 doesn't go into it, 7 doesn't go into it, and now I'm at 8, so then once you find that it repeats, I have all factors. So 1 and 32 are factors of 32, 2 and 6 are factors, and 8 and 4. Now this, I would not say is a good option because even though 1 is a perfect square, 32 is not, so I would not do this option. Now seeing this option, that allows me to recognize that that is the easiest route, that I can take the square root of 16, I can take the square root of 2 and leave that as is, but one step and I'm done. Here, I can recognize that this is a perfect square, but this more needs to be done to it. So this is a really good idea to see the factors ahead of time, and then you can pick the route that you wish to take. So for this next example, I'm going to do it using this strategy and see if we can figure out which is our best route to take. And let's use a big number. So -3 times the square root of 128. So factors of 128. Well, I know that 1 times 128 are factors. I know that 2 times, and at this point, feel free to use a calculator. Just go and say, all right, 128 divided by 1, 128 divided by 2, 128 divided by 3, 128 divided by 4, and just keep going down until you've exhausted the possibilities. So I have 2 times 64. 3 won't go in evenly. 4 does. It goes in 32 times. 5 does not go in evenly. 6 does not go in evenly. 7, no. 8 does. 8 goes in 16 times. 7 does not, or 8, 9 does not. 10, no. 11, no. 12, no. 13, 14, 15. Okay, so here are all the factors. So which of these 4 factors would give us the easiest road to travel? I think it would be this one, 2 times 64. Because if I do 4 and 32, sure, 4 is a perfect square, but then 32, as we just saw, will have to be broken up again. 8 and 16. 16 is a perfect square, but then 8 would have to be broken up again. So these two factors here will get us to our answer, but we're going to have to do more work. The one that's surrounded by these brackets will allow us to do the problem in one breakup. So -3 times the square root of 64 times the square root of 2. Now that I have it broken up, I'm going to simplify the radicals. So -3 times 8 times the square root of 2. And then from here, -3 times 8 is -24 times the square root of 2. So my answer is -24 square root 2. So even with the bigger numbers, having a multiplier out in front, again, we can't distribute it into the radical. We can't just multiply our radicand of 128 times -3. We have to keep it outside, and then we just use it as a multiplier. Any questions with the medium level difficulty ones? Hmm? All right, so I am going to go ahead and give you one to try. Maybe you want to try the suggestion of writing out the factors. I'm going to give you a medium level difficulty one. So there's going to be a multiplier on the outside. Then you want to break it up and then combine it as best you can. All right, go ahead and try this one. All right, so let's take a look at what we could do for this problem here. So let's take the route of listing out the factors. And again, with the calculator, you're free to start off with 56 divided by 1, 56 divided by 2, 56 divided by 3, and just go through until you find a mirrored factor, like 7 times 8, 8 times 7. That equals 56, so then I know that I can stop dividing. So 1 times 56 are factors, 2 times 28 are factors, 3 does not go in evenly, 4 does, 4 times 4, nope, 4 times 14, 5 does not, 6 does not, 7 times 8, and then 8 times 7, and this is what I mean by the reflecting, that 7 times 8, 8 times 7. Once you see this relationship here, you know that it's just going to be the opposites for the rest of the way down. All right, so now seeing these 4 options, which one appears to be the easiest? Well, 1 and 56 doesn't really get us anywhere. 2 and 28 seem nice, but neither one are perfect squares, and 28 would be broken up more. So I don't really want to do this one. 4 and 14, this one seems nice. 4 is a perfect square. 14 can't be broken up anymore because that's 7 times 2, and neither one of those are perfect squares. So I'm going to have 2 times the square root of 4 times the square root of 14 is 2 times 2 times the square root of 14, or 4 times the square root of 14, which is 4 root 14. So even ones that are a little more challenging, great idea to list out the factors and then assess which one would be the easiest route to take. Again, these other 2 could have done, but again, 28 would have been the square root of 7 and the square root of 4. 8 would have been the square root of 4 and the square root of 2. Yes? Question is on spelling. Guaranteed is Guarenteed. I got Enteed. Sure. So the question is, can you show out the 7 and 8? And I would love to. So if we would have done the square root of 7 times the square root of 8 times 2, the square root of 7 can't simplify, but the square root of 8 can be the square root of 4 times the square root of 2. And so what I'd be left with is 2 times the square root of 7 times the square root of 4 times the square root of 2. Now this square root of 4 will become 2. So 2 times 2 is 4. And then to finish simplifying this part off, much like on how we've been multiplying the radicals, I can't do 4 times 7 or 4 times 2, but since these are both radicals, I can multiply those. So it would be 4 times 7 times 2, which is 14. And so like I said, it'll take more steps, but we get to the same end result. So before I move on to the hardest level that we're going to have to simplify, do we have any questions with this medium level? The square root of 4/9, so a fraction. Now, I'm going to approach this problem the same way. I am not going to worry about what fraction times itself equals 4/9. I'm going to treat this as two different problems, the numerator problem and then the denominator problem. So this is the same thing as the square root of 4 divided by the square root of 9. So I am going to first simplify the numerator, the top number, then I'm going to simplify the denominator, that bottom number. Well, I know the square root of 4 is 2, and the square root of 9 is 3. So the square root of 4/9 is 2/3. Now, this is not going to come up much in this class. I just want to show you what a hard difficulty problem would look like. And it's just taking the square root of the numerator divided by the square root of the denominator. So if I had something like the square root of 8/27, what number times itself would give me a simplified answer? And so we'll just keep it simple. So the square root of 8 divided by the square root of 27. Now, if I were just to simplify the radicals, I know that the square root of 8 is going to give me the square root of 4 times the square root of 2. And I know the square root of 27 is going to be the square root of 9 times the square root of 3. So I'm going to simplify these separately and then put them back into my fraction. And so if I were just simplifying my numerator and my denominator, this is the answer that I would get. Now, if we were in algebra and we were taking this course and we were really simplifying this fraction, there's a technicality, I know tons of them, that we can't have a square root in the denominator. Now, that is not a conversation for today. Right now, we're just focusing on being able to simplify the square roots. But just so you are aware that there is a mathematical process to get rid of this square root and to make sure the denominator doesn't have any square roots in them. I just wanted to show you what it would be like to simplify a fraction. Now, you saw in your homework, I did not give you any fractions. On the tests that we're going to be taking, I didn't give you any fractions. I'm going to do my best to avoid fractions like this for the class because, again, I'm looking for the content, not the mathematical ability, not whether or not I can trip you up on fractions. I just want to know, do you understand the process? So just to show you the process, that's what we would end with. If we were going for 100% mathematical accuracy, we would need to rationalize that denominator and get rid of the square root. But we're not going to worry about it. All right, so that is going to go ahead and conclude